Okay. Good afternoon, everyone. Thank you so much for joining us. As the stubble burning season winds down across North India, we at iForest have been closely tracking the prevalence and spread of this intense but short duration pollution activity. Understanding the problem is the first step to solving it, and that's exactly what our team is focused on. Today, we're here to present the Stubble Burning Status Report 2025 based on satellite data observed since October. We believe these insights are crucial to shaping a more effective roadmap for mitigation and long-term action. Without any further delay, here's how the session will flow today. I'll now hand it over to Chandrabhushan, CEO of iForest, who, along with the geospatial mapping team consisting of Ishan Kochar, Meet Makwana, and Manish Bilore, will walk us through the findings. After the presentation, we'll open the floor for media questions. Please feel free to drop your questions in the chat at any time. I'll be curating them. Over to you, CV.
Thank you very much, Shreya. Good afternoon, everyone. And I'm really excited to present this work, which the team at iForest has actually put in a lot of effort to produce since last 2 months. In fact, as soon as the stubble burning season started, the geoinformatics team at iForest started tracking it. And the data that we are going to present to you today is a combination of study that the team has done over the past 2 months. Let me say that we are going to present to you data which is also historical data in terms of what has been the status of stubble burning since 2019, as well as the current data till 27th of November 2025. Some of the data, there is a time lag. It takes time for satellite, for data to be available in a form that can be used. So we are going to present to you the status of stubble burning till 27th of November 2025. Now, before we start this webinar and present to you the findings of the report, let me introduce the team to you. So the team that has worked on this report is headed by Ishan Kochar. Ishan is the program lead at iForest, and he is MSc in Geoinformation Science and Earth Observation. Ishan is from Indian Institute of Remote Sensing, ISRO, and as well as from the University of Twente, the Netherlands. So Ishan comes with vast experience in geoinformation and satellite monitoring. The person next to Ishan who has worked on this is Manish Bilore, is a program associate at iForest. Manish is MTech in Geoinformatics and Natural Resource Engineering from IIT Bombay. He also has MA in computational computation in architecture from Royal Danish Academy School of Architecture. So again, Manish comes with a lot of technical knowledge and experience on these topics. And the third person is Meet Makwana. Meet is a research associate at iForest. He's also a MTech in remote sensing from IIT Bombay. So the three people have worked very hard to provide you an information which we believe is solid as far as science is concerned, and the report has good news as well as bad news. With this, let me now give you some background why it is important today to discuss stubble burning. If you look at the history of stubble burning and actually the discussion around stubble burning and air pollution, you will find that it is around 2010 that reports started coming out on contribution of stubble burning to air pollution in Indo-Gangetic Plain. Around 2008, some research report came out. 2010, many more. In fact, the most comprehensive report came out in 2014. So from 2010 onwards, stubble burning started becoming a villain. And, there was a lot of talk, both from civil society, think tank, research institution, as well as the political class started talking about stubble burning as a main villain for air pollution in Delhi, at least during October and November months. Now, what you see in last 2 years, that suddenly stubble burning has vanished. This year, in fact, was extremely interesting that everyone started saying that stubble burning has nothing to do with air pollution in Delhi. But that's not the case, and this is what we are going to present to you. I also want to say that for the first time, we think that some of the program that Government of India has supported on stubble management is working, and we are again going to present the data to you. So a very comprehensive study, and with this, let me hand it over to Ishan to tell you about the methodology and other aspects of this study. Ishan, to you.
Thank you, CB, for setting the context and how the team has worked on the report. So before we present to you the findings of the report, so let me set the context, like what is the status quo, how Government of India, the CREAMS, which is the Consortium for Research on Agroecosystem Monitoring and Modeling from Space, which is by IARI, which is Indian Agriculture Research Institute. So this is the status quo. And so the status quo is that we use polar satellites, and polar satellite has a limitation that it can only visit any location at a specific time. So for example, the currently Government of India uses a MODIS sensor, which is onboarded on Terra satellite and Aqua satellite. So that Terra satellite, which pass over India around 10:30 a.m. and Aqua, which is again a MODIS sensor, which passes around India at 1:30 p.m. And the spatial resolution is 1 kilometer by 1 kilometer, and you get to see the readings every 1 day. And once the information or the observation is captured, so to the end user, it is available for the analysis or to make insights or to make some interpretations. It's available after 24 hours. So this is a very important factor to know. And then we also have VIRS, which is a slightly better satellite sensor. The spatial resolution is 375 by 375 meters. So when we use MODIS versus VIRS, so VIRS has the inbuilt spatial resolution, that capability that it can detect more number of wires, that smaller number of wires, which the MODIS is not able to capture. And the timing when it passes over India is also 1:30 p.m. And this data is also available to the end user after 24 hours of the observation. So this picture actually gives you an idea that at 10:30 you can see MODIS captures the observation in the morning, and after that there's a window of roughly 3-4 hours, and then MODIS captures it, and around same time VIR also captures this one. So that 3 p.m. split you see. So recently what we have observed, that MODIS, which is a very old program, satellite program, so which started around 2000s. And now it's already 2025, so it's been 25 years in operation. So that MODIS, that program itself, the MODIS satellite, has drifted from its position. So earlier it used to be passing around India and used to capture the observations around 1:30 p.m. But recently what we have observed is that it has moved towards 3 p.m. And this is a very time critical component when we need to monitor such a dynamic activity which is happening on ground, and we need to make quick decisions based on that. So that's why, considering the limitations of the polar satellite, the existing system, so we looked at a triangulated view of the problem, like what we can observe, not just looking at the active fire count from a polar satellite, but I think we should need to look at a burnt area. And there's enough evidence in the scientific community, and there's been enough literature being produced that burnt area tends to give a slightly better picture than just the fire count. So on top of that, since we observed that, and there's been some reports that the timing has shifted to post 3 p.m. or there's a limitation of the polar satellites which are not able to capture the stubble burning or the active fires till 3 p.m. So I think we need to look at the geostationary satellites. So geostationary satellites has the capability that it can it can capture any observation continuously, like it can give you 24 hours of picture. So we used a satellite which captures the earth every 15 minutes. So we have a very detailed understanding within just one day. So going beyond the current metrics, the one highlighted in blue is the addition that our team looked at. So we used Sentinel-2 satellite, which has a inbuilt multispectral instrument, and it passes over India around 10:30 a.m. And we, for the sake of this analysis, and it was a very large scale, and we did it at a state level. So natively, it provides you at a 20 by 20 meter resolution, but for the sake of the analysis, and we were doing the analysis within a very like time-packed manner. So we is to optimize the analysis, we used the 100 meter by 100 meter resolution. But the temporal resolution here is 5 days. So this satellite, once it passes today, it will come back to the same position or the same coordinates on Earth after 5 days. And from this, we monitor the burnt area, what is the impact on ground. And another addition is the geostationary satellite. This is provided by the European Meteorological Department, and we used the readings which is available at every 15 minutes by 15 minutes. And the problem here is, I would not say the problem, but the limitation here is the spatial resolution. We have to make certain trade-offs when we are looking at the entire problem. So there's one satellite which gives you a better resolution, but it has a coarser one resolution. So that's why there's a challenge. So that's why we looked at all three components that to have a better picture, not just looking at the one matrix or the two metrics. We are giving you a like combined metrics approach. So what are we tracking from these three different satellites? One is the burnt area, what the current system is monitoring just the fire count. And the other one, the timing is important. We need to know at what time the stubble burning is happening or the fire activity is happening. So there's one set of satellites which provides you the fire count. There's a second set of satellites which provides you the burnt area. And then there's a geostationary satellite which gives you the timing of the activity, the fire activity. So what it measures, the fire count, it basically gives you the number of fires or the hotspots where it is happening. The burnt area, it gives you the how much the land got burned. And from the geostationary satellite, the timing factor is crucial here. And again, as I mentioned briefly, that it has its own strengths. It can quickly deliver you the data within 24 hours of tracking. The burnt area, which we use Sentinel-2, so it comes to the end user after a lag of around 8 to 15 days. So we cannot make a quick decision, but a better reliable measure to estimate the impact of the land that got burned. And again, with geostationary, this gives you the timing factor. The limitation of fire count or the modest is that it can miss smaller number of fires and especially which are very short-lived, less than few hours. So you get to see that the satellite captures every 24 hours. So whatever the smaller number of fires are the very short-lived fires, unlike the forest fires. So they are not able to capture it. And same with the burnt area, it has its own limitations because you get to see after every 5 days the same area. So it has the tendency that it can miss if there's any change on the ground. So you can miss the smaller number of patches which are being burnt on ground. Again, the geostationary satellite, it has a coarse resolution of 4 kilometer by 4 kilometer. So only large fires, very large fires are getting captured, but it's good to know the timing and the hotspot where they are happening. So the ideal use case when we are looking at MODIS and VRS is good to know the trends, and in case we need some form of alerts, so that's good. And for burnt area, again, it's a slightly better measure to understand the impact on ground. And the burnt area is again further used to estimate the emissions being burned, so the stubble being burnt, and to estimate the emissions coming out of those the fields. So we need to know why fire count and the burnt area, we need to use these two parameters. The single parameters or the single metrics won't give you the entire picture. So it can happen that we have a scenario that fire count, you see, like there are number of fires, like too much, and the fire count you see is very high, but the actual impact on ground is very low. So that means we have to interpret that, there's a lot of activity, thermal activity, but there's a very little damage on ground. So there could be another scenario where you see like if you just count the fires, so it's just like very minimal, 1, 2, 3, 4 counts, but the impact on ground, it has a very high impact, and it burned that like large patch of land, and that is something we need to be very cognizant about. That is the real metric. So instead of using just the single metrics of fire count, I think we need to club the fire count with the burnt area and then get to know what the real challenge is. And so sorry. So the burnt area tells you, just to summarize, like what's burnt area and the fire count is. The burnt area gives you how much land got burnt, which is a proxy of stubble, and it has its limitations that might miss out the smaller number of fires, but it gives you a slightly better picture of the impact on ground. So I'll hand over this to my colleague Manish. So he'll walk you through about how we analyze or count the number of fires on ground. Over to you, Manish.
Thank you, Ishan. It's been a pleasure working on this project. I'll quickly explain the methodology that we have used to estimate the fire counts. Now, NASA firms provides two different data sets, which is VIRS and MODIS. Now, these active fire data sets, they differ specifically in two measures, which is sensor resolution and the detection confidence. The two main sensors, as Ishan explained, are VIRS, which are on board the Suomi and NOAA satellites, and MODIS, which is on the NASA's Terra and Aqua satellites. Terra and Aqua were launched in 1999 and 2002, and Suomi, which carries the VIRS, Suomi and NOAA, both carry VIRS. They were launched in 2011 and 2017. Now, VIRS, which is Visible Infrared Imaging Radiometer Suite, has a higher resolution of 375 by 375 meters. They are capable to detect more small and low intensity fires. MODIS, which is Moderate Resolution Imaging Spectral Radiometer. This is at a spatial resolution of 1 kilometer by 1 kilometer. This is better suited to study long-term trends, especially before 2012. This is because VIRS data was not available before that. But after 2012, the scientific literature and NASA's recommendation says that we should be using VIRS data only. The second measure, which differs the two data sets, is confidence threshold. Now, confidence threshold can be understood as the control between sensitivity and reliability. A 30% threshold captures many more smaller agriculture fires as against the 80%. 80% is a very conservative measure, and they often miss out smaller events. That is why the recommendation says we should be using 30%. So following NASA's guidance and literature by publications, recent publications, in our current fire count analysis, we have used VIRS data at a 30% threshold. Then to focus this data set specifically on crop residue, we have used European Space Agency, which is ESA's 2020 cropland mask. Now, what this gives us is this is the global data set of all the agricultural area. We specifically use this data set to isolate all the fire radiative power signals only to cropland area. Then we use a second filter, which is the administrative boundary given by the Survey of India. And then we isolate these signals specifically to the states. For example, Madhya Pradesh, Rajasthan, we specifically isolate these signals only to these administrative zones and states. That is the entire method of associating the raw signal to the end location, and that's how we count fire. Uh, the second method, the burnt area, which is, uh, in my opinion, a better measure of understanding, but even this has a limitation, but I'll walk you through the methodology. Now, our method specifically focuses on the Kharif season, specifically between the dates of September 15th to November 30 for the years 2019 to 2024. This is a critical period of agriculture residue burning. Now we use Sentinel-2 satellite. The data that we acquire from Sentinel-2 satellites are specifically two bands, which is the near infrared and shortwave infrared bands. These two bands are then processed into something which is called normalized burn ratio, which is NBR. Now, NBR, as you can see on the slide, is a metric of understanding how this indice can be associated to the burnt ratio. We add and then subtract and then we perform basic arithmetic to understand how this burnt area ratio can be associated to the burnt area specifically. Once we establish what the NBR is, we then sequentially place these NBR at every 5 days. So we get a time series of NBR, and then we start getting difference between consecutive NBRs. Now that is called the delta NBR or difference NBR. Now, the difference NBR detects changes in the burnt area over time. This ensures reliable comparison between burnt area. The first is the raw aggregation of NBR, which we observe every 5 days, and then we measure the difference between these NBR images in consecutive periods. Now, the value that we get for DNBR ranges from -1 to 1. Here, the negative value associates to a healthy vegetation. So any value between -1 to 0 is identified as healthy vegetation, and any value between 0 to 1 is associated with burnt vegetation. So in our process, we have associated uh, any value between 0.16 to 1 as burnt area. Now, this is again following guidelines, established guidelines from NASA and other literature. But again, this is not a hard and fast rule. It depends on multiple factors, but with the method that we are using, this is the best foot forward. So to summarize what the burnt area method is, any positive DNBR signal is a potential burnt area. Now, this shows that the land's DNBR has dropped and confirms the recent burnt activity. And this is the systemic approach that lets us track both the timing and intensity of Kharif burning. I would hand over to Meet because these two factors are both from polar satellites, and Meet will explain what geostationary satellites can add to this work chain.
As Manish discussed about the polar orbiting satellites, now I'll let you go through the geostationary satellite datasets. So there is a European organization, EUMSTAT, which provide the data about Indian Ocean active fire monitoring count, which gives us the data in .NET format, which provides the coordinate of the fire count that happened and the time in UTC, at what time it happened throughout the day. It gives us the reading of about 15 minutes a day, which comes around 96 readings a day. So it comes under the satellite Meteosat 9 and Meteosat 8. We have mapped to 2019 to 2025. So for till 2022, we have used the Meteosat 8, and after that, Meteosat 9 that we have used. Geostationary has an orbital position of 45.5 degree east, and the sensor that it used is a SEVIRI, which is a spinning enhanced visible and infrared imager. It has a visible bands and also the infrared and thermal bands. So it is a pixel size of 3 kilometer, but at the nadir view, if a satellite is watching through at a perpendicular, but India is slightly in the right of it, so it has a pixel size of 4 kilometer to 6 kilometer for India, 4 by 4 kilometer to 6 by 6 kilometers. It has a data format in cap XML inside, which can be used to format and data in a manner that we can get about a spatial location of it and a time of it. Next slide. Next. This is the field of view for the particular satellite product that we have used. It can able to cover the whole Indian region, and for our analysis, the Punjab and Haryana can be covered in this region. Now I'll hand over to the CV.
Thank you. Before I give you the findings of the study, it was very important for us to tell you why we used multiple satellite and multiple sensors. As Ishan explained to you, our current protocol for measuring farm fire is inadequate because it is based on polar satellites. Polar satellite passes over India, the overpass over India at a fixed time, and anything that it cannot detect as it is overpassing India, anything that, after that, whatever happens, it will not be able to detect. And therefore, the current method has limitations, in fact, massive limitations, because as you can see, MODIS passes between 10:30 to 1:30, 3 hours. And then VIRS passes at 1:30 once. So of the 24 hours, actually the polar satellite that Government of India's agencies are using to monitor active fire, it is only for a window of 3 hours. 21 hour, there is no eye on the ground to monitor what is happening as far as stubble burning is concerned. And this is for the first time that multiple satellite, multiple sensor analysis is being presented to you. We believe that it gives a very comprehensive picture on what is happening on the ground. So let's start with active fire count. Now, this data everyone has because this data is published by CREAMS, IARI. And as you can see, we have taken 6 states: Punjab, Haryana, Delhi, Madhya Pradesh, Rajasthan, and Uttar Pradesh. Now, as this data shows, from 2019 till 2023, Punjab has the dominant contribution to the number of active farm fire in India. As you can clearly see, the height of Punjab bar. So Punjab and Haryana was almost 80% in 2019, again 18% in 2020, again 85% in 2021, 2022 again about 80%, and then their contribution reduces. In fact, in 2025, Punjab and Haryana contributes about 20% of total active fire count if you consider all these 6 states. And then Uttar Pradesh and Madhya Pradesh now becomes a major contributor to active fire count. So this data is available, and you can see, and this data has been presented by Government of India, and in fact all the think tanks have presented this data. This data was also presented to the Supreme Court. Now let's go, and it shows very clearly that there has been a significant reduction in active fire count in Punjab and Haryana. Now this is the data for Punjab. From its peak in 2020-2021, which was about 71,000 active fire count, in 2025, Punjab is 6,000, about 92% reduction. And there has been a secular reduction every year. This is what MODIS and VIRS is giving us. The same trend is available in Haryana. From its peak of 10,000 active fire in 2021, we are now talking about 1,000 fires, a 90% reduction. Next. In MP, however, we do see that the active fire count has increased from about 8,000 about 5,000 in 2019 to now about 16,000, 17,000 in 2024, 2025. In UP, we see similar increase from about 4,000 in 2019 to 8,000 in 2025. And in Rajasthan, which has a small, fire, the number has also increased. It's about 3,500 active fire in 2025. So MODIS and VIRS is giving us a sense that there has been a 90% reduction in active fire count during Kharif season in Punjab and Haryana, and significant increase in Madhya Pradesh and Uttar Pradesh. This is what VIRS and MODIS are providing us. And this data is being released by CREAMS. This data is being fed into decision support system, which tells us what is the contribution of stubble burning to air pollution in Delhi NCR. This data is widely used because it is a government data. But this was polar satellite, which passes over once or twice over our country. Now, what is geostationary satellite tell us? Now, geostationary satellite is focused. It is fixed. It is giving us data every 15 minutes. The limitation is that it can only capture large fire because the resolution is about 4 kilometer by 4 kilometer. So the large fires, it can certainly capture. Next. Now, before I show you the chart, I want you to understand what the chart explains. The chart basically tells you what is the percentage of daily fire happening at what time. So for example, in 2025, the darkest red line that you see, the chart shows that the fire event has peaked at about 5 o'clock and the number is 50%, which means that 50% of all fires in 2025 were detected at 5 o'clock. So this is what the next few slides is going to show. Next, please. This is Punjab in 2019. Majority of farm fire, please go back. This is Punjab in 2019. The majority of farm fire was recorded at 1:30 in Punjab. Next. In 2020, we do see a little shift, but still majority of farm fire is happening between 11:45 till 3 p.m. There is some spike that has happened at 5 o'clock in 2020. Next. In 2021, when Punjab had recorded 71,000 active fire count, again, majority of fire was happening when polar satellite was looking at India. Next. In 2022, we start seeing the shift. And there is a moderate shift in 2022. By 2023, almost 40% is happening at about 5 o'clock. In 2024, this number is increasing. In fact, most of the fire in 2024 happened between 3 p.m. till 6 p.m. Next. And in 2025, almost all fire in Punjab, something, more than 90%, has happened between 3:30 till 6 p.m. Now, this is what geostationary satellite is showing us. That before 2022, MODIS and VIRS were able to capture farm fire because the timing was before 3 p.m. for majority of farm fire. For 2023, 2024, 2025, MODIS and VIRS are not able to capture majority of farm fire. And therefore, you have such small number, not because someone is tampering with the data, but just certainly because the satellite we are using to monitor farm fire itself is not able to capture it. So this is the story of Punjab. In 2025, majority of farm fire has happened at about 5 o'clock in Punjab. Next. The story is a little different in Haryana. In fact, we find that most of the farm fire in Haryana from 2019 onwards has been happening after 4 o'clock. So this is the picture of Haryana in 2019, where more than 60% happened at 5 o'clock. Next. Again, in 2020, about 50% happened in 2020. 50% of farm fire activity was recorded at 5 o'clock. Next. In 2021, you can see that there is some spread, but again, about 40-50% has happened between 4:45 till 5:30. From 2022, next. 2023, next. 2024, next. And 2025, most of the fire in Haryana is happening after 3 p.m. So we have been singularly underestimating fire in Haryana. Not today, unlike Punjab, where we see the shift happening from on majorly in 2023, 2024, and 2025. In Haryana, the shift had already happened in 2019. So MODIS and Aqua, MODIS and VIIRS were not capturing most of the farm fire in Haryana, even in 2019. So this is the map of Haryana. So once you use the geostationary satellite, and I want this caveat, this limitation very clearly, that this number is only for large farm fire, because the resolution we are talking about here is 4 kilometer by 4 kilometer, whereas in VIIRS the resolution is 375 meter by 375 meter. But this number will capture large farm fire, and therefore what we are showing it to you, as far as large farm fires is concerned, it is now happening both in Punjab and Haryana after 3 p.m., which cannot be captured by MODIS and VIIRS. So this is the real story of significant reduction in active fire count in Punjab and Haryana. Next. What about burnt area? Now again, this we have used Sentinel-2 to estimate burnt area, and as the team told you, it provides a better picture of what is happening on the ground as far as quantity of stubble that is being burnt compared to active fire count. Next. And this is a very positive story. We certainly see active burnt area during Kharif season in Punjab reducing by about 35%. From its peak of 31,000 square kilometer in 2022, the burnt area has reduced to about 20,000 in 2025. Now, because we have data only till 27th November of 2025, so this number might increase a little bit, but overall, there has been 30-35% reduction in burnt area in Punjab as far as during this Kharif season is concerned. It is good news. There is something happening on the ground. Something is working. So this is the story of Punjab. 1/3 reduction in burnt area during Kharif season from the peak of 2022. Next. In Haryana, there's again reduction of about 25% from the peak of 2019. So in 2019, it was about 11,000 square kilometer. Now it is about 8,800. But unlike Punjab, where there's a secular decline from 2022, Haryana, it is fluctuating. It is fluctuating between 7,000 in 2024 to 10,000 in 2023. This year, it is about 9,000 square kilometer. So Haryana's story is a little different story. Unlike Punjab, we see a continuous decline. In Haryana, in some year it is reducing, and it could be because of a variety of factors. It could be because of what is the contribution of basmati versus non-basmati rice, how much stubble is being picked up from the ground. It could be many factors which determines whether a farm is burnt or not. But this year, till 27 November, the Kharif burnt area in Haryana was about 8,800 square kilometer. Next. So what is the conclusion? Next. The conclusion is very simple, that our current protocol is measuring farm fire only during a narrow time window, which is 10:30 a.m. to 1:30 p.m., 3 hours. 21 hours, we don't know what is happening on the ground. And therefore, modest VIRS data is showing 90% reduction in active fire count in Punjab and Haryana. However, SEVIRI geostationary 15 minutes observation shows that now majority of large farm fires occur after 3 p.m. in Punjab and Haryana. For example, SEVIRI data shows that more than 90% of large farm fire in Punjab in 2024 occurred after 3 p.m. In 2021, it was only 3%. In Haryana, from 2019, large farm fires have taken place after 2019, after 3 p.m. Thus, we have been underestimating fires in Haryana for several years. Next. Burnt area, as I said, good news. Sentinel data shows that Punjab burnt area has reduced during Kharif season from 31,000 to 20,000 in 2025, about 37% reduction. In Haryana, it has reduced by about 25%. But Haryana, there's a fluctuation. Some year it has increased, as I explained to you. So while burnt area has reduced, there is 1/3 reduction in burnt area. These reductions are significantly lower than those suggested by active fire count, which is more than 95%. Okay. So, if you use active fire count, you will find that in Punjab, the reduction is about 95%. If you take burnt area, it is about 33-37%. Next. So what is the policy, implication? I think the first policy implication is that there is something positive happening on the ground. Okay. There is reduction in stubble burning in Punjab and Haryana. Whether it is a central government scheme of subsidizing in situ machine, or central government scheme of taking stubble from the farm and giving it to thermal power plant or to boilers or selling to the market, something is working on the ground. And therefore, we see certain reduction, certainly 25 to 35% reduction in burnt area. But 25 to 35% reduction in burnt area is not equal to 25 to 35% reduction in stubble burning volume. So I don't think you should confuse. We cannot estimate the total volume of stubble just based on burnt area. We will need some more data before we can do that. However, still, the total burning is still large scale. We are talking about 20,000 square kilometer burning in Punjab and 8,000 square kilometer burning in Haryana. 28,000 square kilometer of farm area being burnt. And if someone says that it is not affecting air quality in Punjab or Haryana or Delhi NCR, then there is certainly a problem. 28,000 square kilometer of burnt area. And therefore, whoever is estimating the contribution of stubble burning to air quality in Delhi NCR and showing it as 2%, 5%, needs to really look at the methodology they are using. Okay. So we are talking about still large scale burning, which is happening in Punjab and Haryana. But again, the policy implication is what we are doing. There is something right happening on the ground. We need to improve it and we need to further intensify it. The other thing is that stubble burning is now becoming a disease. It was largely centered on Punjab and Haryana. We now see it increasing in Madhya Pradesh, Uttar Pradesh. We see it happening in Maharashtra. We have numbers from Odisha. It is now a disease which is catching the entire country. And therefore, the focus on Punjab and Haryana is not what it should be. We now have to think about what is happening as far as stubble burning is concerned across the country. We now have number from MP and UP, which shows increasing active fire count in these two states. The other policy implication is we need to move from a monitoring paradigm, which is based on active fire count, to now thinking about a combination of active fire count and burnt area to actually estimate the real impact of stubble burning on air quality, on land, on health, and other things. Next. Which means that the decision support system that Indian Institute of Tropical Meteorology is running, they need to revise their methodology. Right now, their methodology is showing 5%, 10%, 15%. Whereas if they start using burnt area, the numbers will be very different. And similarly, CREAMS should start publishing burnt area. It is not a very complicated process. If a small institution like iForest can do it, I'm sure that such reputed and big institutions can also estimate and publish this data. So with this, we have finished our presentation, and we will now open the floor for Q&A. Shreya, to you to moderate the session.
Thank you, Sibi. Yeah. Okay, our first question is from Jacob Koshi from The Hindu. Jacob, if you're there, you can just unmute and ask. Can you put the volume? Can't hear.
Can you hear me? Am I audible?
Yes.
Okay. So a couple of questions. One is, Chandrabhushan, why do you think the government has not been using this burnt area or publicizing the burnt area number? Is it because that data, I mean, that satellite monitoring is, I don't know, hard to come by or something like that? So why that is happening? Secondly, how do I make an inference regarding the most of the fires in Punjab shifting towards the evening time, but there also being a reduction in burnt area? Has it something to do with, because isn't it possible that most of the fires in Punjab are small fires, but now the 5 o'clock stuff only shows you the large fires, as you were pointing out? So how do I fit those two data points? What is the inference from that? Thank you.
Thank you. First of all, I don't think I will not be. You will need to ask, IARI and IITM why they are not, relying on burnt area.
Okay.
For us, actually Sentinel satellite is a far more the resolution actually is we can actually calculate burnt area at a resolution of 20 meter by 20 meter. Of course, that will require huge amount of resources. We have done it at 100 meter by 100 meter. But, it's a very precise measurement. It is used across the world for fire detection, especially for forest fire. But it is a very, very standard product. This is not something which is new. Everyone knows this. So we think that you will have to ask government why that data is not being publicized. As far as the question on burnt area reducing, as I said, there's no correlation between number of active farm fire and burnt area. You might have 1 lakh active fire count and the burnt area might be X. And you might have, 50,000 active fire count and burnt area could be X multiplied by 5.
Okay.
So do not correlate at all the number of fire count with burnt area. Okay, they are two separate indicators. As Ishan explained to you, they have their own value. Active fire count is very quick. You can see if you want an alert system, you can use. You can pinpoint, send a regulator to stop it. Okay. Again, there's a gap of about 24 hours. Okay. Even active fire count data you get after 24 hours. In case of burnt area, you get after, a week. So, so they both have different function. So I don't see any correlation. But as I said, burnt area gives you a much precise picture of what is happening on the ground. And we do see reduction, 1/3 reduction in Punjab, about 25% reduction in Haryana, as far as Kharif burnt area is concerned.
So just to follow up on that, the headline question remains that is always asked is stubble burning reducing from Punjab and Haryana? So
our estimate, the headline, and we can say with as much confidence the data has given us, there is reduction in stubble burning in Punjab and Haryana to the extent of 25 to 35% measured from burnt area.
Yeah, but as you said, there is no correlation between fire counts and this. So
not at all. In fact,
then are you basing the fact when you're saying as a headline statement that stubble burning is reduced, it means purely from a burnt area perspective, right?
Yes, of course. In fact, we should not be using active fire count as an indicator to measure how much stubble is being burnt.
Okay.
It is a very poor indicator. I am not sure why it was picked up. Maybe because from alert point of view, IARI would have decided to pick it up. But if I have to measure what is happening on the ground, active fire count is a very poor indicator.
Okay.
And that too from polar satellite, which is only measuring for 3 hours.
And also just to add on,
Jacob, if you don't mind, there are tons of questions. We'll just come back to you.
Sure.
Can we move to Srishti Chaudhary from CNN News 18? Jacob, I'll be back with you again.
Sure. Okay.
Thanks.
Hi, everyone. Can you hear me?
Yes, we can hear you.
Yes. So I just wanted to ask, so despite the data inadequacies, it's quite clear that stubble burning has declined when it comes to Punjab and Haryana. So when we discuss all the pollution sources, because the discussion is in light of Delhi pollution, do we see any, similar reduction in other sources? Because when it comes to all the different sources of pollution, I think the kind of reduction we have seen in stubble burning, it doesn't really compare to other sources. So, what are your views on this?
First of all, you must understand the quantum we are talking about of stubble burning. Okay. A kg of a stubble burnt is equal to a ton of oil burnt in an automobile. Let me repeat again. The pollution coming out of a kilogram of stubble is equal to pollution coming out of 1 ton of petrol or diesel you burnt in your automobile. Simply because in automobile there is a catalytic converter and a filter, and also oil is a cleaner fuel. Stubble is solid fuel, burns poorly, and there is no control equipment. So 2 things. 1, the intensity of pollution from biomass is extremely high. Number 2, the quantity we are talking about is millions of tons. Okay. So even if there is 1/3 reduction in stubble burning in Punjab, the burnt area still is 20,000 square kilometers. And therefore, the contribution of pollution still is extremely high. So while I'm giving you a positive story, it doesn't mean that the pollution contribution from stubble burning in Punjab and Haryana doesn't matter now. As has been, people are talking about as if it doesn't matter. It didn't matter this year. Okay. 8,000 square kilometer of burnt area in Haryana, 20,000 square kilometer of burnt area in Punjab. These are big numbers. And I'm not giving you because we are not very confident to put out the number on actual quantity of stubble. We have done some estimation, but our confidence level is not that high. Maybe after a month, when we have done all, we have done all the due diligence, we will put it out. But the number is just unimaginable. In 2 months, the amount of stubble we are burning, the pollution impact is across Indo-Gangetic plain. And you can see this from satellite. The plume that you see over Indo-Gangetic plain is not possible from industry or automobile. Let me say that. Okay. It is not possible. That plume can only happen from short duration, high intensity burning activity. And you can see that plume moving across 3,000 kilometers from Lahore in Pakistan till Bangladesh. Okay. No number of industry and automobile can create that kind of plume. So it is still a significant source of pollution. The good news is something is working on the ground, and we need to intensify that effort.
Thank you, CB. I'll move to Nidhi Jamwal. Nidhi, if you could please unmute yourself and ask your question. I just want to request everyone else to raise a hand. It'll help us, sift through the long list of people. So please do raise your hand if you have a question.
Hi, Nidhi.
Are you there, Nidhi? Okay, she's typed her question, CB, so I'm just going to read it out. I have two questions. Nidhi, are you there?
Yeah, can you hear me?
Yeah, please go ahead. Yeah.
Okay, yeah. Hi, CB. Thanks for a fascinating presentation as always. I had two quick questions. One is you've used the geostationary satellite data, which is 4 kilometer into 4 kilometer resolution. So what you're presenting to us, does that mean that it could still be an underestimation because, the resolution is so high? And my second question is the kind of analysis you have done from 2019 to 2025 for Punjab and Haryana. Is that also available for maybe UP and MP? Any, some reports of that? That's it. Thank you.
Thank you, Nidhi. You're absolutely right. We are underestimating because the resolution is 4 kilometer by 4 kilometer. So this data is not able to capture, smaller fires. Smaller means even 1 kilometer by 1 kilometer fire, it will be difficult to capture. So yes, we are underestimating it. That is number one. But not burnt area. Burnt area, it's a very precise 100 meter by 100 meter. It could have been more precise with 20 meter by 20 meter. And therefore, we have not presented to you from geostationary satellite the fire count. We have only presented to you the timing of fire. Otherwise, it would have confused everyone. Modest VIRS numbers are very different than the geostationary SEVIRI data. SEVIRI data is even much lower, as you rightly said. It is underestimating the number because it is only capturing large fires. So that is number one. Number two, we have done some analysis of UP and MP, but for only about 6 districts, and therefore we are not presenting to you. Let the fire season another couple of weeks, we will get all the data, and then maybe we will present even UP, MP, and Rajasthan data to you.
Thank you. We have a question from Sadiqur Rahman Barua, who says, what is the perceived reason of significant declining of stubble burning in Punjab and Haryana? What drives MP and UP to increase burning?
So I think there has been focus on Punjab and Haryana. Since 2018, central government has spent 4,000 crore rupees, in $500 million in providing in situ machinery. There is now a mandate from thermal power plant to pick up stubble. We do see now, private sector entering and collecting stubble and then taking it to industries. So there are things happening in Punjab and Haryana. So there is something happening and something is working. The same focus is not on UP and MP. Also, the paddy area has increased in UP and MP. So there's almost, plateauing of paddy area in Punjab and Haryana, whereas there is a significant increase in paddy cultivation in UP and MP. That data is available. We should have presented the data to you, but that data we have. In terms of acreage of paddy cultivation, in MP, it is a rapid increase. So you now have more paddy area in MP and UP, and therefore we do see increase in burning.
We'll move next to Kalyan Ray from Deccan Herald. Kalyan, if you're there, can you please unmute yourself?
Hello.
Ha,
Yeah,
Kalyan.
Kalyan, we can hear you.
Yeah. No, I was wondering that if somebody is spreading a message to the farmers, let's do the firing after lunch or around 3 o'clock, is there an organized effort by somebody on the ground to tell the farmers? I'm sure the farmers themselves may not be doing all these calculations. They must be just getting a message.
I cannot answer that, but I have seen television program in which, farmers have said to the, journalists that they were informed beforehand. But we have not done that ground truthing. Our team was there on the ground, by the way. During the our fire season, our team was on the ground in Punjab and Haryana, and but we were not able to confirm that. But certainly, I mean to say, uh, uh, if there is such a shift happening, and then some information would have gone to them. But we have not confirmed that.
Okay, okay.
Srishti Jain, are you there? Srishti, your question is, what are the drivers of the differential farm fire timings in the two states?
Again, the same answer. I don't know what is the driver. Is it a deliberate information to farmers? Is it convenience? I don't know. But but satellite can tell us that the shift has happened. It cannot tell us the reason why that shift has happened.
So, just continuing on that question, thank you for the presentation. So, there are no specific reasons as to why even Haryana shifted to post 5 p.m. in 2019, while Punjab has seen that trend only in recent years.
Yeah. We have no idea. Again, Srishti, it is very difficult, the geostationary satellites are very reliable because the focus is there on a geographical area. So the SEVIRI data is this is the focus. The SEVIRI MSG field of view is this, and therefore we can see we have looked at from 2019. You can even go back and see. Okay, but Haryana, as I said, it started. We are seeing a large fire happening after 3 p.m. in Haryana from 2019. What was the reason? Very difficult to know. Very difficult.
Thank you.
Chetan Bhattacharjee, are you there, Chetan?
Hi,
It's from the Health Policy Watch. Yeah, please go ahead.
Okay, my question is this, that what is your IFOREST estimate of the fire count in Punjab and Haryana this season?
We cannot test it. As I said, Chetan, VIIRS data is 130. Burning is not happening at that time, so it is impossible to estimate the number of active fire count. Therefore, we are giving you burnt area. No one can estimate active fire count accurately now. If the burning timing has changed, you cannot estimate it. You have nothing, no eye on the ground. So there is no satellite which is looking at the time when the farm burning is happening. There is satellite which can, Sentinel, which can measure the burnt area, but active fire count you cannot now. No one can tell you accurately how much is the active fire count.
There's a follow-up to that. Can I continue?
Yeah.
Yeah, the follow-up is this, that Dr. Hiren Jethwa has been posting, and I spoke to him also. He's used multiple geostationary satellites to triangulate, or however they do this, and he's come to one particular count. It may be inaccurate, but it's a ballpark figure.
We have been working very closely with Hiren.
This will be finished. Of 57,000 fires. Would you agree with that estimate?
This is we have been working with Hiren since last year. In fact, before we published it, we had a discussion with Hiren. Hiren is using a South Korean satellite called ComSat. Ishan, is that the name right? Ishan? What is the name of that South Korean satellite?
Yeah, so it's ComSat.
It's ComSat. Okay. So Hiren is using that satellite, but again, that satellite is looking at Northwest India at an angle. So Hiren has developed an algorithm on number. It is his estimate, but we have not confirmed. We have not looked at that number. We have not looked at that algorithm. Okay.
Just
ComSat. Ishan, please go ahead.
Okay. Just to add, so there's an Indian satellite, geostationary satellite called INSAT 3DS. So we have been trying to look at that data also, but we were not able to publish the results, but so these were European satellite which we used, which again looks at India at a very certain angle. Then there's a Korean satellite which looks from a different angle. I think that we need to come up at a better picture and to look at the timings. I think we need to look at the geostationary satellite from an Indian organization, from ISRO, which is INSAT 3DS?
The disadvantage of geostationary satellite, because they are at 36,000 kilometers away from us, okay, their resolution will always be coarse. Okay, their resolution will not like polar satellite.
No,
So
I understand that, but thank you for your response. The only reason I ask is because apparently ISRO has also come to the same conclusion as you and Hiren, and they also have a count. I don't know what their estimate of count is. So I was just wondering if you would be arriving at a count.
anyone who is counting it will now count it through algorithm and extrapolation. But the satellite count will not be. So Hiren is also extrapolating.
Got it.
But
So you
as I
won't
said,
be
I am not at all interested in number of active fire count.
No,
For
I
me,
understand
it is
that,
a very
but
poor
I
indicator.
understand that, but most of your report has also been on fire counts. So I just wanted to understand that you would not be doing that or pursuing that study at
No,
all.
we are not doing that. We
Okay,
will
got it.
rather focus on burnt area
Yeah, got it.
and improve and make it much more precise. Yeah.
Got it. Thanks.
Moving on, there's a question from Rekha Dikshit from the IIT Madras Shastra magazine. She says, as a recommendation then, what would you suggest for reducing winter smog?
Reduce stubble burning, eliminate it. I mean to say that would be ideal. Reduce, pollution from other sources. We still have a lot of work to do on thermal power plant. The standards are still have been delayed. Move to electric vehicles, electrification of automobile. Most importantly, shift cooking and heating fuel. The other estimate, maybe we'll come back to you after some time, is to tell you the contribution of cooking and heating fuel. Winter becomes very important because we use large amount of solid fuel for heating. Close to 70 million tons of heating fuel is used in India just for a month. And, so heating fuel, which that angithi that you see in everyone's house, is a major cause of pollution. So cooking and heating fuel shift is also important. I have been saying for a long time that air pollution will require, transition in energy. Our current energy source is dominated by solid fuel, coal and biomass. Till we reduce solid fuel, we will not see significant reduction in air pollution.
We have another question from Nikhil Ghanekar from the Indian Express. Nikhil, if you're there, can you please unmute and ask? It's on burnt area mapping that can be validated.
Hi, can you hear me?
Nikhil, tell me.
ISRO also flagged this issue recently of how the timings of what time the fires are set on the fields is shifting, and that undercounting bias is there. What I wanted to come to was that, I mean, this issue has been put before the Supreme Court since last November. How this has been a problem, undercounting bias. In fact, the ComSat and other geostationary satellite issue was discussed before Supreme Court, and there has been a burnt area mapping protocol that is being developed by the CAQM and ISRO IARI. My question to you is that how can we now go ahead and efficiently validate the mapping of burnt area? Because that is also another challenge here. There are course resolutions mapping different kinds of fires also apart from farm fires. So would you like to comment on that as well? Essentially the mapping of, I mean, the validation of burnt area mapping.
So I will now ask Manish to give you the answer. But yes, you are absolutely right. The validation is extremely important. The resolution is extremely important. And I'm really happy to hear that, and I have seen that ISRO paper from Nimisha Singh. Nimisha has been publishing a lot on, Manish, if you can mute yourself for a minute. Yeah. Nimisha has been publishing a lot on stubble burning, and the latest paper is a fantastic paper. And very correctly saying that in 2024, most of the burning has moved beyond 3 p.m. So I'm happy that if CA, QMS, and and ISRO are working on the methodology, that methodology we all should use, standardize and use it. So Manish, you can tell us about how validation is done.
Thank you for the question. Basically, what we are doing is we are mapping DNBR and we are taking sequential imaging. Now, the best way to validate this is to identify a small area where we can actually be on the ground and uh, keep a constant look throughout the entire fire season, and then correlate our satellite findings with the on-ground findings that we have. And this method is time consuming, human resource consuming. So the best way to estimate is satellite, but I agree that we need to do a thorough validation of this. And this cannot happen only on one point. This has to be repeated on multiple locations across multiple, at least one entire year across multiple locations to get somewhat of a course mapping or using on field, and then satellite mapping can come in and fill in the entire picture, and then we can produce a very valid result. So this is the way of doing it.
Nikhil, it is similar to what Forest Survey of India does. Okay, they take sample plots. So satellite gives them an idea on tree cover, tree height, and other things, and also burnt area. FSI also uses burnt area product, and then they have sample plots across India where they validate it. So validation cannot happen only from satellite. The real validation will happen with sample plots. And we should invest in that. It is very important that we have a very robust ground truthing process to validate all these results.
Just one more thing to add.
Supplementary, that
So
how do you
on the
eliminate
validation part, just wanted to add. So
Sure,
if
sure.
ISRO is coming up with a burnt area and giving you certain numbers, and we are coming up with certain numbers, so I think the one way to compare and validate is that we should be using the same satellite and same resolution, then the methodology becomes comparable. And if their methodology, let's say, is giving you results at a 1 meter resolution and we are estimating at a 10 meter, again there'll be a drastic difference between both the studies. So right now what we are doing is, because we were in the favor of using just VIRS because that gives you a best estimate at a best resolution. But creams, I'm talking about the fire count, and creams, they use MODIS and VIRS, and they are both giving you, at 1 kilometer and 375 by 375 meter. But when we compare 375 with 1 kilometer, there'll be a huge difference between both the observations. You're on mute, CV.
Let me show it to you something which I have kept in annexure for you. Can you go back to the annexure, please? Why resolution matters. Next. Can you go back to the annexure? Go back to the annexure. Okay. Now, this is the data only from MODIS. So MODIS in 2025 has a fire count of 7,000. Just 7,000 across all 6 states, because MODIS resolution is 1 kilometer by 1 kilometer. Next. This is VIRS with a resolution of 375 meter by 375 meter. Here the fire count in 2025 is 33,000. So which satellite you are using, what resolution you are using, all these will need to be standardized, Nikhil, so that we get a much more accurate data as far as stubble burning is concerned.
My supplementary was just very quick supplementary was on how did you ensure that there is no duplication with other kind of fires, so open burning, etc. types.
In that case, go back to the methodology, please. Okay. So there is a deduplication process. Can you come? Okay. There's a deduplication process that is used also to remove anything which is not farm fire. So there is a method. Again, there is a methodology that is used to remove duplication. To make sure that you are not capturing, say, for example, an industrial fire or something which is happening there. So there is a standard method to do that.
And also to add, we are using a cropland mask, that we are using a land use land cover map, and we are extracting the agriculture area out of that. And whatever stubble burning or a fire count we are presenting, it's attributed just to the agriculture fires or the agriculture land, not anything beyond that.
Okay.
Thank you.
Thank you.
We are almost at 10 minutes to 4, so I'm going to cap this at 3 more questions. We have a question from Chetan Bhattacharjee, who says, what is IFOREST's estimate of stubble burning's share in Delhi's air pollution this October to November period?
Can't say that. Again, we have not done that estimation, but it's certainly not 5% or 10% that decision support system data is showing, because they are, the number they are using and feeding into the system itself is underestimating the fire. So we have not done that estimation, but it is certainly not what is coming out of DSS.
There's a question from Dr. Pragya Nathani from Manav Vikas Sansthan, an NGO. She says that, under the super cedar, partial burning area is increasing. So are we including partial burn area in burnt area?
Yes.
If not, what can be done to take that into consideration?
In fact, there is nothing called as standardized burning. Farmers are not burning in a similar pattern. Some are burning fully everything. What is left after a combine harvester, the chaff coming out of after the grain is removed. So some are burning everything. Others are burning only partially, what is left after combine harvester. Some are actually collecting everything and burning in the heap. And then there is a permutation combination. So there's no standard way to do it. But yes, under this, partial burning would be covered. So would be some of the large collection burning. But again, after all, it is satellite. It is kilometers away from us. And then that sensor is giving us data. There will always be plus minus. Some fire which will be captured and some which will not be captured. Even at 375 meter by 375 meter resolution or 100 meter by 100 meter resolution. So yes, this was a very important question for us, and I had asked team, and in fact given this assignment to the team, that are we able to capture partial burning or not? And they came back, said that yes, we will be able to capture it.
We'll move to Madhukar Brar, who has his hand raised. Madhukar, can you please unmute yourself and speak?
Hi, my name is Madhukar. I work for Air Pollution Action Group. It's a non-profit. I had just one comment to make about some of the questions. Someone asked why this shift from from the peak of 1:30 to 3:30 p.m. So I led the stubble burning initiative of APAG in Punjab, and I was stationed at the Department of Agriculture and Farmer Welfare in Punjab, Chandigarh. In 2022, a handwritten timing of satellite was circulated on WhatsApp among farmer and farm groups. By that, they were aware of satellite timing. I can name the IS officers, but I would refrain from doing so.
Oh, don't do that on this platform, please.
Yeah. So I can IS officers and deputy commissioners in different districts whom I had met, and they were openly telling farmers to burn after 3:30, 4 p.m. This year also, I myself did some ground truthing, traveled around 2,000 kilometers across Punjab, and a very clear pattern which I noticed was earlier you could see some fire before 3:30, 3 p.m. between 1:30. This year, as if they were waiting for 3:30, 3:35, and then suddenly you'd see hundreds and thousands of fires. All district. I come from Punjab and from a wheat and paddy cultivating family. Same cycle. My cousin who travels across Punjab for his business and all, they report similar number of fires happening year on year. I had one question I forgot to ask, but I'll stop myself. Yeah.
Thank you very much. Thank you. Our team was also there in Punjab. My colleagues were there, and they also came back with the same story that that the timing has significantly changed. Yes. Thank you.
Sneha Jadhav, are you there? You've raised your hand. Or else we'll move to Ayushman Sabu and we can call it a close after this.
No, Shreya,
Ayushman?
continue. I'm not in a hurry. Whoever wants to ask, please ask them. Let them. We should be able
Okay.
to
It's conscious
answer
of time.
every doubt and every question.
Sure. Ayushman, are you there? Sneha or Ayushman, if you can raise your hand.
Or maybe they can type in the chat.
Yeah, you could actually drop your question
Hello,
in.
can you hear me?
Yes.
Hi, I'm Sneha Jadhav. I have one question about the methodology. You said that the overlapping detections were removed. Can you tell me how you did that?
Manish?
Hi, this is specifically for MODIS and VIRS data. So now we know that MODIS covers at 1 kilometer by 1 kilometer and VIRS is at 375 meters by 375 meters. So the way we deduplicated the data is that we took both the data and resampled them at roughly about 1 kilometer by 1 kilometer. So if we assume the data to be on the equator, the pixel size will be 1 kilometer by 1 kilometer. So once we this process is called resampling. So once we take both these data on the same resolution, then we can identify, okay, if the fire count that's coming from VIRS and MODIS is at the same coordinate and is at the same time, then we drop the MODIS data. We only give preferential treatment to the VIRS data because the scope of our data is from 2019 onwards. So once we resample both the datasets on the same resolution, check if they are on the same coordinates and on the same time, we drop the MODIS data and we go with the VIRS data. And then we go back to the original scale and the final estimate is what we have. This is the deduplication method.
Thank you.
Right. Thanks, Manish. Sneha, I think her question is, have you quantified the emissions from stubble burning in this report?
No,
which
we have
you've
not.
already answered.
Okay.
Hi, can I
But
go
we will
ahead
be
now?
able to tell you in a couple of months. Yeah, Aishman, please go ahead.
Yeah, please.
Thank you for the presentation. Just wanted to ask about the validation. So was there any ground truthing done for the algorithm? And if not, what would you say is the accuracy of the burnt area algorithm you've developed?
So right now there was no ground truthing done. Okay, we are presenting to you as it from satellite using a standard product and a standard methodology. It is also very difficult for us to pinpoint a percentage accuracy to you right now. Okay. But these are standard product, Ayushman. This is not, they are widely used across the world. The ground truthing would have certainly enhanced the accuracy, okay, and would have allowed us to, refine it further. But these are standard product data. So in both the count, we will not be one that we have not validated it with ground truthing. Number two, very difficult for us to give you a percentage figure on accuracy.
Yeah, one form of validation is we did was the whatever the published literature is, and we were in the same range, whatever the literature is, because
Yeah,
when
I
you
mean to say that is fine, but that is not validation.
that is
That is
not the ground validation.
you are using same standard method. This is what you are doing. It's not validation. Yeah.
Okay, I'm just going to go back to Jacob. He had a follow-up question. Jacob, are you there?
Yeah, I'm here.
Please.
Just a quick follow-up, from the burnt area picture and given that, the agricultural department has data on district-wise on what is the area under paddy, can't you just combine them together and estimate the quantities of stubble that is being burnt? And, from that, estimate the particulate matter and, it's whether the burnt area reduction actually corresponds to a reduction in pollution. I mean, so ultimately that's the million-dollar question that we have to estimate, right?
Jacob, we are in the process of doing it. तुम तो पहले ही,
Okay, so
we are in the
I'll
process.
wait for that. Okay.
We are in the process of doing it. We know exactly what is the paddy area. Okay. We know what is the burnt area. We will get some idea on total paddy production and biomass. We are waiting for paddy production estimate to come. Okay? We have past data. So we are in the process of doing it. But again, whatever we will give it to you is an estimate. It would always benefit through ground truthing. क्योंकि जैसे the farmers are not burning in a standardized fashion. Some is just burning a foot of stubble left after combine harvester. Some are burning everything. Some are taking everything together and burning it in a heap. So there will always be a uncertainty on quantum, but we are in the process of doing something, and we should be able to give you some answer in couple of months.
Look forward to that.
Thank you.
We have a question from Manish Sharma, who says, as you've mentioned the usage of solid fuel, or as you've spoken about the usage of solid fuel, in your understanding, what specific percentage falls in the use of, I think essentially he's asking that, solid fuel reduction, how much of air pollution will that really contribute to? In how much time will we start to see these results?
Immediate. I mean to say pollution is, you attack the source goes, the pollution goes. Okay. But I just want to tell you, India consumes burns about 2 billion tons of material. As a country as a whole, we burn about 1.2 billion ton coal, maybe 500 million tons of biomass, 600 million tons of biomass. So coal and biomass is about 1.7 billion ton, then 50 million tons of natural gas, 125 million tons of petrol and diesel, then solid waste. So if you put everything together, in terms of material we burn in this country, 85% is biomass and coal. So at least 85% of, rough calculation on air pollution. If air pollution is smoke, then 85% is from burning coal and biomass. It's a very simple, construct. Of course, you can do much more refined estimation, but no country in the world, and I keep making this point, including China, has reduced air pollution without reducing solid fuel. The biggest attack in China to reduce pollution in Beijing was coal. They reduced from 30 million tons coal use to less than 5 million tons, and shifted all coal consuming industry outside Hebei, Tianjin, Beijing, region. So, and the other major contribution which people do not talk about is heating policy, clean heating fuel policy of China. The heating fuel requirement in China is even much more higher than us because of a much colder climate. So the second major thing that China did was to come out with something called as clean heating fuel policy to replace solid fuel as a heating fuel. I'll encourage all of you to look at it. We are, stubble is one story, but now in December, January, you will have large scale use of heating fuel in India, which will contribute to air pollution. We are not talking about it. So, my answer is that you attack the source, reduce the quantity, and you will see the result very quickly.
Thank you, CB. And I think with that, it's a wrap. I think we've taken all the questions.
So thank you very much.
Closing remarks, yeah.
Our presentation will be on the website. This webinar will be on website. The summary of our findings will be on website. There's a press release which will be on the website, and we look forward to extending this. We are extending this study, and we look forward to your support, in taking this message forward. Thank you very much, and I want to thank the team, Ishan, Manish, and Meet, who have worked very hard to get this data to you, and we will continue to get you high quality scientific information. Thank you very much.